This video covers one of the most important topics, if not the most important topic that we learn new in this course. This is the topic of replacing conditionals with polymorphism. This is a refactoring rule, and let me explain what the idea is using the whiteboard. Let's look at this class, sum class. Assume there are lots of fields and methods, but we are focused on just a small part of this class. We have a field, sum field, and a method m. I put a return type of void here. I don't have any parameters here, but that could be changed. I mean, that is not the most important aspect. What I have here is some code to do some stuff. We are talking in the abstract. So there is some code that is done initially. Then we check the value of this field. And if it is equal to 1, we do some stuff to perform some action 1. If some field is equal to 2, we do something else. And if the field is equal to 3, this is something else. There are some misspellings, and this is not quite a Java syntax, but this is more pseudocode than pure Java. So look at how this whole thing flows. Some common stuff, then depending upon the value of field, we do different things. So we have conditionals, if, else, if, etc. And this could go on, actually. We could have more legs of these conditionals. When you have such a method, the method is going to behave possibly differently depending upon the value of this field, some field. When that is the case, we should consider refactoring this method. In fact, not just this method, this class itself. Actually, it is going to be somewhat major. What we should do is recognize the fact that this method has different behavior depending upon the value that is in some field. So what we need to do then is actually create one subclass for each of these different fields. So if some field is 1, that indicates a new class. If some field is equal to 2, we have a new class. Some field is equal to 3, that gives rise to a third class. What we then do is create a superclass. I'm calling it superclass. This method m goes into the superclass, and we put the common code here. And we have other members that they are not quite important in this context. Then for each of these legs of the conditionals, we are going to have one class, public class, sum class 1, extend sum class. That is for this leg of the conditional. Then for the second leg, we have a second class. And for the third leg, we have a third class. And in each of these, we override m. So there is a version of m in some class 1, some class 2, and some class 3. And what you do in m is, in some class 1, we call super.m. So the common code gets executed. Then we copy this code here, code to do action 1. Similarly, in some class 2, we call super.m to do the common stuff. And then we do the special actions for action 2, the steps for action 2. And similarly in some class 3. So we have replaced the conditionals with polymorphism. The reason being, if we need this behavior, action 1, we create an object of type sum class 1. If we need the second behavior, we create an object of type sum class 2. Otherwise, we create an object of type sum class 3. So how does it work when the client uses this code? So imagine a client, and previously the client used to create an object of type sum class and set this field to a certain value. If it was 1, when the method was called, it will perform this action. And if the field was 2, and when the method m is called, it will perform action 2. Similarly for action 3. Now, instead of doing this, we have the client creating an instance of type sum class 1 and then calling s.m. This field has disappeared, and s.m will go here and perform the same actions that m performed in the original version. So in the original version, the code performed some common stuff and then action 1. Here, the same thing happens. So we have a polymorphic assignment here. S equals sum class 1. S is of type superclass. So s.m uses dynamic binding to go to this method and perform the actions. We have replaced the conditionals with polymorphism. We don't have any conditionals related to some field anymore. And this is the right object-oriented method or approach. I meant method meaning approach. This is the right approach to design. So when you find that you are switching on a field or sometimes switching on a parameter, it is time to think whether you can replace those conditionals with polymorphism. Sometimes you cannot do that. And very often you can. So if the behavior depends on the type of the item, we add a new type. That is what we have been discussing. The book and periodical are different types of objects. So they behaved differently. So we should have different classes for them. So this is the refactoring rule, replacing conditionals with polymorphism. Move each leg of the conditional to an overriding method. That is, we create a new subclass in which this method is placed. If you don't have anything common, you may make the method in the superclass abstract. So in the case of the book and periodical, we are going to have a common superclass, an ancestor, and it would be like this: public abstract class, loanable item implements matchable string, and book extends loanable item, periodical extends loanable item, and we put all the common fields and methods in loanable item, so they are not repeated in book or periodical. But some methods will be special to book and specific to periodical. So we will see the revised design shortly. But when you create an inheritance hierarchy, you should have a very clear view of the abstraction that we are introducing into the system. So here we are having this loanable item with the idea that it will be subclassed for future expansion. And we said we will put all the common members, methods and fields into the superclass. we should try to make the methods as general as possible so that they can be used from all the subclasses if they need. And the design should be such that changes are easier. And sometimes you might want to make certain fields protected or sometimes private, and very rarely public. So think about the proper access modifiers, and always do not have any reference to a subclass in a superclass. The superclass is supposed to be designed first, and it should not have any dependence on the subclasses.